Hello everyone, myself Professor Shilpa Patil, working as an assistant professor in the Department of EEE, Sai with the Institute of Technology, Bangalore. In this video lecture, we are going to discuss about a Quine-McCluskey technique. Right? In earlier lectures, we already discussed how to simplify an Boolean expression using K-map. Okay, so in a K-map, we have observed that the adjacent minterms can be reduced. The adjacent minterms can be reduced because they are differ by a single letter. Okay. In a similar way, the Quine-McCluskey also uses a same technique to reduce the minterms by combining the minterms whose binary representation is differ by a single place, that is by a single bit. Okay, so here in a Quine-McCluskey method, so we are tabulating the minterms which are differ by a single bit. Then we will start comparing the minterms which are differ by a single bit. Then we will go for the simplification. Okay, so this Quine-McCluskey method is also called as an tabulation method. Okay, so now we will have a solve a Quine-McCluskey method to get an prime implicants. Okay, first in a Quine-McCluskey method, we have to list the minterms in a binary form. So whenever an Boolean expression is given, you have to list the minterms in a binary form. Then only you can find out a single bit change between the minterms. That is a first step. Then you have to arrange the minterms according to the number of ones. Right? So if first we will place a minterm which doesn't have any ones, then we will place the minterms which has a single ones, then two ones, like that we will continue. Right? Once you arrange the minterms according to their number of ones, then we will start comparing the minterms of one group with an adjacent next higher group, and we will see whether they differ by an only one position. If they differ by only one position, then we will copy that minterm group to the next column, and then we will put a check mark, and we have to place a dash in the position in which position they differed. Okay, so that dash will indicate in which position they differed, and we are putting a check mark because that group is moved to the next column. If we have not put a check mark to any of the minterm, that indicates that minterm cannot be reduced further. Okay, then that is a prime implicant. Okay, then once you start comparing the groups and moving to the minterms group to the next column, then again in a step 4 we have to repeat a step 3. Again we have to compare one group to the next adjacent higher category. Then we have to pass on the minterms group which is having a single bit change. Okay, once this comparison is over, then we have to list all the prime implicants which doesn't have a check mark. Right, then select the minimum number of prime implicants which must cover all the minterms. Okay, so these are the steps to be followed while solving the Quine-McCluskey method. Okay, right, take down the first problem now. So here we'll take a first problem. Simplify the following Boolean function by using Quine-McCluskey method. F of A, B, C, D, summation of M 0, 2, 3, 6, 7, 8, 10, 12, 13. Okay, so we will follow the steps. So what is our first step, students? First I have to list down the minterms and I have to give the binary representation for the minterms. So I have listed the minterms here. Whatever the minterms are given in the expression 0, 2, 3, 6, 7, 8, 10, 12, 13. Now we will write the binary representation for these minterms. Okay, so since we have four variables here, so I will represent a binary representation in 4-bit. Okay, now so this is my first step. Then we will go to the second step. What is the second step? I have to list the minterms, okay, according to their number of ones. Okay, so first I will take a minterm which doesn't have any ones, so m0, right, which doesn't have any ones, so that is one group. Then search for a minterm which have a single ones. 2, 8 are the minterms which has a single ones, so we will make a 2 and 8 as an another group. Okay, then search for the minterms which has a 2 ones, 3, 6 and 12. So we will make 3, 6, 10, 12 as an another group. Then search for the minterms which has a 3 ones, 7 and 13. So 7 and 13 we will make an another group. Okay, so this is a second step. We have arranged the minterms based on the number of ones. Okay, now we will start comparing the minterms of one group with an adjacent higher group, right? So now I will start comparing this 0 with 2 and 0 with 8. Okay, right. So now we will compare 0 with 2, the minterm 0 with minterm 2, whether they differ by a single bit position. Yes, they differ by a single bit position in a third place, right? So what we have to do, we have to pass on 0 to the next column, placing a dash in a third position, right? Then we have to put a check mark to the 0 and 2. Okay, similarly compare 0 and 8. Yes, they are differ by a single bit, right? So in a first place, right? So that is MSB. So I will pass on 0 and 8 to the next column, and I will put a dash in a first place, and I'll put a check mark to the 0 and 8. Okay, right. So 0 is compared with its next higher adjacent group. Then we will compare minterm 2 and 8 with 3, 6, 10, 12. Okay, so now we will compare minterm 2 with minterm 3, whether they differ by a single bit. Yes, they differ by a single bit, so I should move those minterms to the next column by placing an dash in a last place. They are differ in last place, right? So 2, 3 I will pass on to the next column, placing the dash in a last place, and we will put a check mark to 2 and 3. Right, similarly compare 2 and 6, whether they differ in a single place, single bit. Yes, they are differ in a single bit in a second position, so I will pass on 2, 6 to the next column, placing a dash in a second place, and we will put a check mark to 2 and 6. Then compare 2 and 10, whether they are differ in a single bit. Yes, they are differ in a single bit in a first position. So move to 10, placing a dash in a first position, and put a check mark to 2 and 10. Then 2, 12, whether they differ in a single bit. No, they are not differ by a single bit. Okay, so the two I have compared with the minterms of the next higher adjacent group. Then we will compare 8 with the minterms, right? Minterm 8 is compared with 3. So whether they are differ by a single bit? No, they are not differ by a single bit. Then 8 and 6? No, they are not differ by single bit. Then 8 and 10? Yes, they are differ by a single bit in a third position. So I will move 8 and 10 to the next column, placing a dash in a third position, and we have to put a tick mark to the 8 and 10. Then compare 8 and 12. Yes, they are differ by a single bit, right? So in a second place, so I will pass on as 1 dash 0 0. Okay, Right. Now we will compare the min terms of a third group, that is 3, 6, 10, 12 with 7 and 13. Okay. Right. Compare 3 with 7. Yes, they are differ by a single bit in a second place. So I'll put 0 dash 1 1. Okay. And we have to put a check mark to the 3 and 7. Similarly, compare 3 and 13. No, they are not differ by a single bit. Okay. Right. Now compare 6 and 7. Whether they differ by a single bit? Yes, they are differ by a single bit in a last position. So put a dash on a last position, 6, 7, right? 0, 1, 1 dash. So we will put a tick mark to the 6 and 7. Right? If it is already having a tick mark, no need to put, but you have to follow that rule. Right? Then compare 6 and 13, whether they differ by a single bit. No, they are not differ by a single bit. Okay. Right. Similarly, compare 10 and 7. No, they are not differ by a single bit. Then 10 and 13. No, they are not differ by a single bit. Okay. Right. Then we will compare 12 with 7. Whether they are differ by a single bit. No, they are not differ by a single bit. Now compare 12 and 13. Whether they differ. Yes, they are differ by a single bit in a last position. So I will move 12, 13 to the next column by placing a dash in a last bit and putting a check mark to the 12 and 13. Okay. So we have compared all the min terms with the last group, right? So this is a step 3. Okay. In step 4, again we have to repeat the step 3 to see whether these min terms can be reduced further, right? So again we will start comparing 0 2 with the next adjacent group min terms like 2 3 2 6 2 10 8 10 8 12. Okay. Right. So first we will compare 0 2 with 2 3, whether they differ by single bit. No. Right. Then 0 2 2 6. No. Then 0 2 2 10. No. Then 0 2 8 10. Yes, they differ by a single bit in a first position. So I will move 0 to 8 10 to the next column by placing the dash in a first position, and in third position it was earlier itself, right? Now we will put a tick mark to 0 2 and 8 10. Okay, similarly compare 0 2 with 8 12. No, it is not differ by single bit, right? Now compare 0 8 with 2 3. No. Then 0 8 with 2 6. No, they are not differ. Then 0 8 with 2 10. Yes, they are differ by a single bit in a third position, right? So I will move 0 8 2 10 to the next column by placing a dash in a first place, that is dash to 0 dash 0. Okay, right. Then compare 0 8, sorry, place a check mark to the 0 8 and 2 10. Okay, right. Now compare 0 8 with 8 10. No. Then 0 8 with 8 12. No. Right. So this is a first and second group. Now we will compare the third and fourth, sorry, second and third. Okay. So we will compare 2 3 with 3 7, whether they differ by a single bit. No. Then 2 3 and 6 7. Yes, they differ in a single bit in a second position, right? So I will move on 2 3 6 7 to the next column by placing a dash in a second place and put a check mark to 2 3 6 7. Okay, right. Similarly 2 3 12 13. No. Right. Similarly check for 2 6 3 7, whether they differ. Yes, 2 6 3 7 is differ in a last position, right? I will move 2 6 3 7 to the next column by placing a dash in a last position and put a check mark to 2 6 and 3 7. Okay. Again start comparing 2 6 with 12 13. No. Right. Similarly compare 2 10 with the 3 7. No. 2, 10, 6, 7, no, 2, 10, 12, 13. Okay. Similarly, you can compare 8, 10 with all the three minterms group and 8, 12 with all the minterms group. You will not get any single bit change. Okay. That indicates you further you cannot reduce the minterms, right? Then now just see here. So 0 to 8, 10, 0 to 8, 10 have a same minterms. Okay. So we can take it as a single minterm group. Even 2, 3, 6, 7, 2, 6, 3, 7. We can take it as a single minterm group. Okay. So this is a final simplification. Now we can list out the prime implicants. Okay. So the prime implicants are the expression for that binary representation which doesn't have a check mark. Okay. So take down the terms which doesn't have a check mark, check for all the columns. Okay. In last column we have 2, right? And in third column we have 2, 8, 12 and 12, 13. In second all are having a check mark, right? So we will have a prime implicants, right? So 8, 12, 12, 13, 0 to 8, 10, 2, 3, 6, 7. Okay. Then the representation for 1 dash 0 0 is 1. 1 means A, right? For B we have reduced it, right? 0 means it is C bar. 0 means D bar. Similarly, you can write the expression for the other minterms, right? Then sum all the product terms whatever you have got, that is nothing but the prime implicants for a given boolean expression. So this is how we will simplify a given boolean expression using Quine-McCluskey technique, or we call it as a tabulation method. I hope everyone